Mathematics made simple. I'm here specifically to look at grade 9 mathematics, and our topic 1 is square roots and cube roots. We are going to look at our topic 1, which is square roots and cube roots. So in our lesson 1, today we'll look specifically at square roots. But before we do that, I want everyone to get a book and follow what has been prepared. Now, you cannot find what a square root is before you know what a square is. What is a square? A square is a product of an identical factor multiplied twice. A square is a product of an identical factor multiplied twice. Let's look at our example. 0 times 0 is equals to 0. 1 times 1 is equals to 1. 2 times 2 is equals to 4. 3 times 3 is equals to 9. 4 times 4 is equals to 16. 5 times 5 is equals to 25. 6 times 6 is equals to 36. 7 times 7 is equals to 49. 8 times 8 is equals to 64. 9 times 9 is equals to 81. And 10 times 10 is equals to 100. Now, these answers we have found after multiplying a number by itself twice are what are known as perfect square numbers. So when we multiplied 0 times 0, we got this 0. When we multiplied 1 times 1, we got a 1. When we multiplied 2 times 2, we got a 4. When we multiplied 3 times 3, we got that 9. When we multiplied 4 times 4, we got that 16. When we multiplied 5 times 5, we got that 25. When we multiplied 6 times 6, we got that 36. When we multiplied 7 times 7, we got that 49. When we multiplied 8 times 8, we got that 64. When we multiplied 9 times 9, we got that 81. And when we multiplied 10 times 10, we got that 100. So, perfect square numbers are 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. Now, let's look at an example. We have an example here. The question is, determine whether the following are perfect square numbers. So we are looking at A, 36, B, 48, and C, 81. Now, when you are asked to determine whether numbers are perfect square numbers, what you are supposed to use are prime numbers. Prime numbers are used to determine perfect square numbers. Now, what are prime numbers? Prime numbers are numbers divisible by 1 and the number itself only. Prime numbers are numbers divisible by 1 and the number itself only, meaning prime numbers are those numbers where only 1 and the number itself are factors. Our set of prime numbers are, we have 2, which is the first prime number. Then we have 3, 5, 7, 11, 13, we have 17, 19, 23, 29, and so on. So the prime numbers are what we are going to use to determine whether those are perfect square numbers. Now let's go to 36. When you're asked to determine whether a number is a perfect square number, there are 2 methods that we use. The first one we are going to use is the table method. So in the table method, that is the table that we have. You use prime numbers to determine. So we are going to say 2 into 36 is 18. 2 into 18 is 9. Are we supposed to use a 2 again? No. Why? Because when you divide 2 into 9, it's going to leave a remainder. You are not supposed to leave a remainder. So you go to the next prime number, which is 3. So you say 3 into 9, 3. 3 into 3, 1. Now, when you are dividing prime numbers into a number, at the bottom here, you are supposed to have a 1. So after you have found that one, then you can express 36 as a product of its prime factors by multiplying 2 times 2 times 3 times 3. Let's do that. So we have 2 times 2 times 3 times 3 giving us 36. From here, what are we supposed to do? Group them so that we have an identical factor. So I'll pick this 2 and that 3, this 2 and that 3. So we are going to say 2 times 3, 2 times 3. So when we group those factors, if you multiply 2 times 3, you're going to get 6. 2 times 3 is giving us 6. So we have an identical factor, which is 6. 6 times 6 is giving us 36. 6 squared is equals to 36. Therefore, 36 is a perfect square number. Let's go to the second method. The second method is known as the tree method. So we'll start with 36. We'll still use prime numbers. The first prime number we are going to use is 2. So we are saying 2 into 36 will give us 18. 2 into 36 is 18. We'll leave that prime number and concentrate on the 18. So we'll divide again. Which prime number are we going to use? We'll use 2 because it's not going to leave a remainder. So we'll say 2 into 18, 9. We'll leave that 2. We'll concentrate on the 9. Then we'll divide. Which prime number are we going to use? We'll use a 3. 3 into 9 is 3. So after that, you have to take note that at the bottom here, the prime number is supposed to be the same if it is a perfect square number. So take note, the prime number at the bottom is supposed to be the same. So we'll still express 36 as a product of its prime factors by multiplying 2 times 2 times 3 times 3. So we express 36 as a product of its prime factors. Then from there, what are we supposed to do? Group the factors so that we have an identical factor. So I'll pick these 2 and that 3, which is that one. That 2 and that 3, which is that one. What am I getting? We have 6 times 6 equals 36. 6 squared is equals to 36. Therefore, 36 is a perfect square number. Let's go to the second example. We have 48. We'll still use the 2 methods. We'll start with the table. We'll use the prime numbers. We'll start with 2. Let's divide 2. 2 into 48 is giving us 24. 2 into 24 is giving us 12. 2 into 12 is 6. 2 into 6 is 3. Am I supposed to use a 2? No. We'll go to the next prime number, which is 3. 3 into 3 is 1 because we are supposed to have a 1 at the bottom. From here, we are going to express 48 as a product of its prime factors by multiplying 2 times 2 times 2 times 2 times 3, which is that. From there, what are we supposed to do? Group the factors. We are supposed to group the factors. 2 times 2 times 3 cannot be grouped with 2 and 3. So those cannot be grouped. Since these cannot be grouped or paired, what can we conclude? We'll conclude that 48 is not a perfect square number. 48 is not a perfect square number. Meaning there's no number which you can multiply by itself twice to get a 48. Let's go to the second method. We'll use the tree. We'll start with 48. We'll still divide using a prime number. So we'll start with 2. 2 into 48 is giving us a 24. We'll leave this 2 and concentrate on the 24. We'll divide again. So we are saying 2 into 24 is 12. We'll leave that 2. We'll concentrate on the 12. We'll divide again. 2 into 12. 2 into 12 is giving us a 6. We'll leave that 2. We'll divide again. Then we have 2 into 6 giving us a 3. So you'll find that at the bottom here, the prime numbers are different. They are not the same. Even before we try to group, we can conclude that this is not a perfect square number. So from here, we express 48 as a product of its prime factors by multiplying 2 times 2 times 2 times 2 times 3. So we are multiplying 2 times 2 times 2 times 3 to give us 48. Can those be grouped? No. These cannot be grouped or paired. Therefore, we can conclude that 48 is not a perfect square number. Let's go to example C. Example C, we have 81. We'll start with the table method. There's our table. Are we supposed to use 2? No. We cannot use 2 because 81 is an odd number. Meaning, when you divide 2 into an odd number, it's going to leave a remainder. So we'll go to 3. 3 into 81 is giving us 27. 3 into 27 is giving us 9. 3 into 9 is giving us 3. 3 into 3 is giving us a 1. From here, what are we supposed to do? Express 81 as a product of its prime factors by multiplying 3 times 3 times 3 times 3. So, when you multiply 3 times 3 times 3 times 3, what are we supposed to do? Group the factors. So, group them like that. After grouping them, you find that when you multiply 3 times 3, you are going to get a 9. 3 times 3 is giving us a 9. So, we have our identical factor, which is 9. 9 squared is equals to 81. Therefore, we can conclude that 81 is a perfect square number. Let's go to the second method. Our second method is the tree method. So start. We'll divide a prime number into 81. We'll divide the prime number into 81. So we are saying 3 into 81 is giving us 27. We are saying 3 into 81 is giving us 27. We'll leave that 3. We'll concentrate on the 27. Again, we'll divide 3 into 27 is giving us a 9. We'll concentrate on the 9. If you divide 3 into 9, we are getting a 3. Express 81 as a product of its prime factors by multiplying 3 times 3 times 3 times 3. Let's do that. So we have 3 times 3 times 3 times 3, giving us 81. Then what are we supposed to do? Group the factors. Group the factors. So when you group them, you find that 3 times 3 is giving us 9. 9 times 9 is giving us 81. So our identical factor is 9. 9 squared is equals to 81. Therefore, we can conclude that 81 is a perfect square number.